Hello, it's Miss Keen. Today's topic is functions. So we're going to determine what are functions and what are not functions. So on your screen, you see definition of a function. So for something to be a function, it is every input has to have one unique output. All x values are paired with one unique y value. And that means that x coordinates cannot repeat with different y coordinates. So let's take a look at what that means. Okay, so here is another example. And I put the definition at the top of the screen. A function is a relationship where one input has exactly one output. So there's a table there. And if you look, it says that, get a pen. So here's your input. X is your input and Y is your output. So when you input 0, you only get one output. When you input 2, you only get one output. When you input 4, you only get one output. So that does meet the definition of a function. So back to the definition. A function is a relationship where only one input, okay, so where only one x has exactly only one output, y. So in each of these cases, one input, one x, had only one solution, which is y. So this is an example of a function. And you can see here at the bottom, I put something very helpful. It says input x, and there is only one possible answer for y. Okay. Let's go to the next screen. All right, on the next screen, same definition at the very top. A function is a relationship where only one input has exactly one output. So let's take a look at this table. So our input is our x, just like on the previous table, and our output is our y. So let's just pause for a second and look at the difference between this table and the previous table. If we look on the input, the x side of the table, there's something different about this table, this input. Okay. So you might have noticed right here, there's a duplicate on the input. So if we think about this, if we input 3, okay, so if we have an input of 3, or if we have an x value of 3, then we're going to have multiple outputs of 4 and 11. So an input of 3 is going to give us an output of 4 or 11. So by definition, when we have one input, so when x is 3, we have more than one output. So this does not reach our definition of what a function is. So in this case, this is an example of something that is not a function. So when this happens, when you have that duplicate, when you have more than one x that has multiple outputs, that is not a function. So in this case, we have a value of 3, that's an x, and the y is equal to 4 or 11. So this one is an example of not a function. All right, let me show you some more examples. Okay. So here we have some other examples. And we have 3 examples here. If you want to pause the video and try to take a educated guess based on the previous 2 examples of whether these are functions or not a functions, you can. And remember the definitions from the first slide of for every one input, there can only be one output. So whenever we input get a pen. Whenever we input one value, we can only have one output. So whenever we input, in this case 10, there's only one possible output, and that's 9. Input 5, one possible output. Input 0, that's one possible output. Input -5, that's one possible output. So this one is a function. Input -4, one possible output. Input -2, one possible output. Input 0, one possible output. Input 2, one possible output. This one also is a function. You may have noticed that those are the same number, but the definition is for every input, there can only be one output. So when we have x is equal to 0, there's only one possible answer, which is 14. And when x is equal to 2, there's only one possible answer. It just happens to be the same number, which is 14. And our last example, when x is -1. So here, when x is -1, well, when x is -1, we have two possible outputs, 4 and 8. So y can be equal to 4 or 8. That makes it not a function. That's your scenario that makes it not a function. Okay, so we have that one possible input, x is equal to -1, but what makes this not a function is when that y value, that output, is equal to multiple numbers, in this case 4 or 8. That makes that not a function. And you can see the difference here between the different tables of what it looks like to be a function and not a function. All right, I have one more slide for you, just see an example, and that'll be it. All right, last example. Okay, one of these is a function and one is not a function. Okay, take a moment, try to figure it out. For every one input, there can only be one output. Your x value is your input, your y value is your output. Every time I input 1, I only get one possible output. Anytime I input 2, I only get one possible output. Anytime I input 3, I only get one possible output. Anytime I input 4, one possible output. That is a function. It's okay that they're all the same number. That's okay. Versus over here, anytime I input number 4 or x equals 4, I get an output of 1, 2, 3, or 4. That makes that not a function. I have multiple outputs for that one input of x equals 4. Those are your two different scenarios in a table of recognizing when you have a function and not a function. Okay, that's it for now. Thank you.